Have you ever really thought about the invisible shield that protects pretty much everything you do online? Well, in this explainer, we're going to pull back the curtain on one of the most important technologies out there, encryption.
You see it all the time, that tiny little padlock up in your browser's address bar. We're always told it means the site is secure, but what is it actually doing? How does that little icon stand guard over your passwords, your messages, your credit card numbers? That's exactly what we're about to break down.
All right, so to really wrap our heads around this, we have to start with a really simple but super powerful idea that's at the heart of it all: digital locks and keys. At its core, encryption is basically the digital version of putting a letter inside a locked safe. It takes your information and just scrambles it into a secret code. The only way to unscramble it and read the original message is if you have the exact right key. This simple idea, it's the foundation for all of our digital privacy.
So the first and most direct way to do this is something called symmetric encryption. You might also hear it called secret key encryption, and honestly, the name kind of gives the whole game away.
The process is super direct. Imagine you lock your message in a digital safe with a physical key. Then you send that locked safe over the internet. Now for the person on the other end to open it, they need an identical copy of the very same key you used. Simple, right? One key locks it, and that same key unlocks it.
And that simplicity, that's its superpower. Because it's just using one key in a really straightforward process, symmetric encryption is incredibly fast. I mean, blazing fast. And that speed makes it the perfect tool for protecting huge chunks of data all at once, like when you encrypt your entire computer hard drive.
But, and you probably saw this coming, right? There's a catch. This super simple, super fast system has one giant, and I mean giant, flaw.
This flaw is so fundamental, it actually has its own name: the key exchange problem. And believe me, this is the kind of problem that kept the world's best code breakers up at night for a long, long time.
So here it is, the big question. If you and your friend both need the exact same secret key to talk securely, how do you get them the key in the first place? If you just email it or send it in a message, a hacker could just snatch it out of the air. And the moment they have that key, it's game over. They can read every single message you send. Your security is totally gone.
Solving this incredibly dangerous problem required a stroke of absolute genius. And that solution takes us to our next chapter: asymmetric encryption.
So instead of relying on one shared secret key, this system uses two different keys that are mathematically linked together. It's a really clever one-way relationship. This is where things get really, really brilliant.
Okay, so here's the big difference. With this system, you get two keys. First, you have a public key. Think of this like an open padlock that you can hand out to absolutely everyone. Anyone in the world can use your public padlock to lock a message in a box just for you. But, and this is the magic part, the only thing that can open that padlock is your unique, secret, private key, a key that only you have. And just like that, poof, the key exchange problem is completely solved. You don't have to worry about anyone intercepting your key because the most important one, your private key, never ever goes anywhere. It's just an incredibly elegant solution.
So we've got one system that's fast but has a big security flaw, and another that's super secure but a bit slower. So which one does the internet actually run on? Well, the answer is both of them. Welcome to the hybrid approach.
The logic here is just fantastic. It's like, why choose between speed and security when you can just have both? The modern internet cleverly combines the strengths of each of these systems to create something that's both ridiculously secure and incredibly efficient.
Okay, so here's what happens in the blink of an eye every time you connect to a secure website. First, your browser uses that slow but ultra-secure asymmetric method, the public padlock system, for one job and one job only, to safely create and share a brand new temporary symmetric key with the website. Then, once that single-use key is securely delivered, both sides switch over to the super-fast symmetric method to encrypt all the actual data for the rest of your visit.
As our source material put it so well, this gives you the speed of a single key with the high security of a public-private pair. It really is the best of both worlds. You get that ironclad security for the initial handshake and then lightning speed for everything else.
So, after all that, what does this actually mean for you and that little lock icon you see every single day? Let's bring it all home.
Literally every time you log into a website, buy something online, or send a sensitive message, this exact hybrid system is working silently in the background, protecting you. It is the engine that powers all digital trust and keeps your private information private.
When you boil it all down, it comes down to this simple equation. The modern internet that we all depend on, one that's safe enough for our banking and fast enough for streaming movies, is only possible because of this amazing combination of speed and security.
And that leaves us with one final and really important question. We've built these incredible digital locks, but hackers are always building better digital lockpicks. With things like quantum computers and advanced AI on the horizon threatening to break what we have now, the race is already on to invent the next generation of security. So you have to wonder, what will it take to protect your secrets in the future?